Hey everyone! It's been a year since my last video, and I'm finally back to share everything that's happened over the past year. In this video, I will talk about the challenges that we faced while making mechanics like water physics, lighting, terrain generation, dynamic skybox, and at the same time keeping the game performant. But before moving on, I want to say huge thanks to everyone for all the nice comments on our previous video. We do read all of them, and they really motivate us to keep going with development. The first thing we worked on was water physics. Our goal was to make water that has volume and is not infinite. So we made each block contain 4 levels of water, and it spreads out if there's nothing to hold it. This means the water in a lake is not infinite. You can drain it, move it, or shape the lake however you like. My brother was in charge of all the calculations for water physics, and my task was making sure that the water would look like water and would behave like water, meaning it had to flow smoothly, something I haven't seen to be honest and had no idea how to do. My first attempt was to generate the mesh with code, store animation in the UV data, and then animate it by changing shader parameters. This kind of worked, but there were way too many shapes and variations that we needed, which was too much for my brain to handle. The code also was too long and had too many if statements, which wasn't great for performance, so I eventually gave up. My second attempt was using SDF, which was great for achieving liquid shapes and smooth animations. The way that SDF works is that you just send an array for each pixel, and after traveling a certain distance, it checks the distance of all the available points, and if it's within range, you fill it with color. As you can imagine, making this many calculations on each pixel costs a lot on the GPU, especially if the water covers a big part of the screen. To reduce the number of pixels, I created a completely different scene that was rendered at low resolution, and used that render to fill the water in the main scene. I also tried to use as few points as possible and played around with distance checks to make the minimum amount of calculations. But the performance was not always good. Even at the lowest possible resolution, the frame rate wasn't stable when there were too many water pixels on screen. The third attempt was kind of similar to the first one, but instead of making the mesh from scratch with code, I just created various parts of water, like we were already doing for the tiles. Then merged the right parts, added animation, and that was it. Now it's performant, and I can have as many variations as I need without torturing myself. We also added waterfalls, which works pretty much the same way. During this period, I was trying to distract myself from water mechanics by making things like explosives, and I also updated the look of the environment. There was another challenge that I was facing right from the beginning of the game, which was lighting. We really wanted to have a day-night cycle and allow our players to place as many lights as possible in the game. But adding default dynamic point lights would have cooked mobile devices, and the number of lights would be extremely limited even on PC. The first obvious thing that I tried is something that developers usually do in 2D games. I placed a big plane over the view and coded a shader where I could add up to 50 lights with different colors and radius. Performance was fine, but it didn't look as good as we wanted, and it was kind of obvious what was actually going on behind the scenes. My second solution was changing the source code of the engine. So I opened the main shader and added code that adds a custom light to the vertex shader. I was able to have 100 real-time moving lights, each with different radius and color, with only 10 FPS drop on Galaxy S7, so each light did cost only about 0.1 FPS. But still, I was thinking about other solutions, because it was not only about lighting. We also have caves, and we needed to be able to darken certain parts of the terrain. Also, since there were no option to have arrays in GLS2, the code for 100 lights looked horrible, something illegal to do. So I had this brilliant idea to just let my brother do the job. And he did. And it turned out very well. The way it works is that my brother calculates the lighting for each block, puts it on a texture, and then I use that texture in my shader. Now we can have pretty much unlimited lights in one view, since we only need to calculate it once when it's placed. For moving lights, we just calculate the affected chunks in the background and update the texture, which is only 32 by 32 for each chunk. We also update the lighting when the player adds or breaks a tile. Corners look darker and more natural, and caves are also dark. Another thing we've added to the game is the skybox. We wanted the game to have dynamic weather and a day-night cycle. So I added a sphere to the game and wrote a shader that draws everything on it. Clouds, sun, moon, stars, even shooting stars. To keep things performant, I moved the sky to a different scene and rendered it at low resolution. And I think that the pixelated look fits the game's art style. I also added a lightning effect, but it was just a separate model and I just changed the world's ambient color. Because we went with smooth round terrain instead of square blocks, the GPU had quite a lot of triangles to render. Since there was no point to have detailed meshes for distant terrain, my brother added a new code that generates terrain with the least triangles possible, which allowed us to show further distances. The old animations that we had were not that great, so I replaced them with new ones. We also added new models for customizing the character. We added a few new animals and made a bonding mechanic where you can bond with them by feeding a cookie. Then we added few enemies that you and your pet can fight with. We also added new factories, a merchant with buy-sell mechanics where you can negotiate the price. Recently we also changed the name of the game to Tenkemo, because we felt that the old name didn't really describe the game well. And we also found out that scammers had bought the powerscures.com domain and were trying to convince people to download the beta version of the game from their website. So this time we bought the domain right away. We also decided to change the monetization model of the game. Back then I used to work on mobile games, and from the beginning the game was planned only for mobile. The thing is, putting a paid game on mobile stores only works for a few extremely popular games, and going free to play is pretty much the only way there. Otherwise, the game will most likely drown among aggressively monetized free-to-play games. And since I already had experience with free-to-play monetization, we planned the game to be free. Later on, we thought that the game should be also playable on PC, so we thought, let's just put it on Steam as a free game too. But during this period, we realized that PC gamers hate microtransactions and free-to-play elements, especially for a game that also have single-player story mode. So we decided to keep the free-to-play elements out of the PC version and make the game paid with a reasonable price. Because the game is going to have a multiplayer mode, one thing that I'm not sure about yet is whether we should sell items that don't affect game balance, like character customization items, to keep the servers alive as long as possible, or we should just get rid of all microtransactions. As a mobile game developer, it's really hard for me to imagine a game with no microtransactions at all. And I can see that many successful PC games don't have any, which is impressive, and if that's the right way to do on Steam, we will do it. So please let us know in the comments which route we should take. We are still working with Godot 3.6 because of mobile performance. Back then, Godot 4 didn't support vertex lighting, which was critical for mobile devices, but they recently added it. I was excited to finally migrate to version 4, but looks like it still is not mobile friendly. I tried playing around with all the settings, but still couldn't reach 60 FPS even with an empty scene. I know, it's a 9-year-old device, but still, I think it should be able to render an empty scene at 60 FPS, when it can render this scene at full resolution. So I'm hoping that Godot development team will look into mobile performance in the next updates. We wanted to participate in the DevGam Lisbon event this year, and we had no option but to make a playable demo. So if you'll be at the event, you can visit us and try the game. Since we already have something playable, our plan is to polish it and prepare it for early access in the upcoming months. Throughout development, I've been listening to music from an artist called Pemsky Cry. You've probably heard some of his music too. And I was super excited when he agreed to make the soundtracks of our game. I'm really hyped that our game will have good soundtracks, because this guy is super talented and I definitely recommend you checking out his music. Looks like that's it for now, and I'll see you guys in the next video.